Hi guys, so this is just a quick video to go over the part 1 of review for your final. So sorry for the background noise, my little one is in here. So yes guys, I'm going to try to do it in about 2 to 3 videos, so it's not too much. Happy New Year's guys, I hope you're having a happy new year. I am combining my second cohort with my first cohort now, so you'll probably see that change when you don't see your own group anymore. So for the final exam guys, I want to make sure that you do know that there's actually 25 questions. So yeah, there will be 25 questions. I just finished taking the exam again. For some reason I thought it was 20 like last year, but it's actually 25 questions. So you do have 25 questions on the exam. It's pretty easy guys. So vocabulary, I'm giving you vocabulary. Can I give you vocabulary words that will exactly be on the test and you just have to look them and match them? I don't think I can, but these slides were magically added on there. So do with them what you want if you want to have easy access to them while you are taking your exam. I mean, it is an open note exam. It is completely up to you. But yes, it is up to you what you want to do with these beautiful vocabulary words with correct definitions. That would give you 3 correct questions on your exam. But again, that is up to you what you want to do with them, because I can't give them to you directly. But if you find them in a review and decide to use them, that is completely up to you. So moving on from that, they do test you on molar mass. So for molar mass guys, whenever you have this parentheses and you have a subscript behind it, what you need to know is that you need to distribute. So I like to write them out. I have aluminum, I have 1 nitrogen, but because I'm distributing the 3, I have 3 nitrogen, and then 3 times 3, that tells me I have 9 oxygen. So then all you have to do is go into the periodic table and find the mass. So again, you go to aluminum, you go to whichever element you're looking for. So from here, I know that aluminum, I'm going to multiply it by 27 grams. I round it up just to give me better looking numbers. So after you multiply it guys, you can add it together. So here I have 27 plus 14 times 3, that gives me 42. And then I add 16 times 9, that gives me 144. So my total molar mass for this, I just add up all of those values and I should get something around 213 grams per mole of aluminum nitrate. So that would be your final answer. You can pause me here so you can practice for the next one. Okay class, so for this next one, you again just have to distribute. So I like writing out barium, I have 1. This oxygen, I originally had 1, but now I have 2. Hydrogen, the same thing, because I'm distributing, because it is inside the parentheses, I have 2. Again, I go to my periodic table to find the mass. So for barium, it's about 137. Oxygen is about 16 grams, and hydrogen is about 1 gram. So again, I add it all up. I multiply, and then that value I add it up. So I have 32 grams here, and 1 times 2 is 2 grams. So I add 32 plus 2 plus 137, and I should be getting somewhere around 171 grams per mole of barium hydroxide. Very easy guys. I think all of these questions that I'm going over today are easy and you can gain them for the exam. Remember, the final exam is 20% of your grade. It is very heavily weighted. Okay guys, isotopes. So how many protons, neutrons, and electrons do the following isotopes have? Protons, neutrons, and electrons. This is something we learned before. It is pretty easy. So if you remember the standard notation, here is the charge. So really quickly guys, here is your mass. Your atomic mass is on the top, and then your atomic number is on the bottom. So an easy way to find the atomic number, I'll do this one first, so I have protons. Protons is the same thing as my atomic number. Then I have neutrons, and then I have my electrons. So when I want to work this out, class, protons, neutrons, and electrons, I go to the periodic table. So I'm looking at B. B is boron. So when I go to boron, I see that my atomic number is the number on top, which is 5. So boron has an atomic number of 5. This makes my job a lot easier. I know I have 5 protons. I don't have a charge, class. So because I don't have a charge, that tells me that the number of protons equals the number of electrons. So electrons, I would also have 5 electrons. And then neutrons, to solve for neutrons, it's pretty easy. All you have to do is subtract your mass minus your atomic number. So my mass here I know is 11 because that top number is my atomic mass. The atomic number is 5, so I have 6 neutrons. Neutrons has a 0 because it has no charge. Use the exact same process to answer the next one, class. You can pause me right here and then check your answer. Okay, guys, so here we have carbon. Again, I'm looking at the symbol. My mass is 14, but I'm still needing the atomic number. So I go to the periodic table. I see that carbon, the atomic number is the number on top. So it has a atomic number of 6. And that atomic number helps me a lot. I don't have a charge, so that charge tells me that my number of protons equals my number of electrons. So protons, electrons, and neutrons. So I have 6 protons, I have 6 electrons, and the number of neutrons again is mass minus atomic number. Based on this setup, I know that my mass is on top and my atomic number is on bottom. So all I have to do is subtract 14 minus 6, and that will give me my atomic number. So 14 minus 6 will give me 8. So I have 8 neutrons, and that's it, guys. Super easy. This is a way you can gain points on that exam. This question is even easier. You have to know that on the periodic table, if they're on the same groups, this is the columns. So you start off with number 1, and then you go all the way to number 8. So this is your alkali metals, and this is your noble gases. That's how you see it on the periodic table. If they're in the same group, they have the same number of valence electrons. So depending on the group you're in, 1 through 8, that tells you how many valence electrons we have. So I'm going to look at nitrogen and phosphorus. So for nitrogen and phosphorus, let me just add a page real quick. Let me add the periodic table, guys. Here we go. So here we have groups 1, 2, 3, 4, 5, 6, 7, and 8. Again, they're columns going down. So depending on whatever group number you're in, that's the number of valence electrons that you have. So again, I was looking at nitrogen and phosphorus. These are in group 5. So they are in the same column. Columns are the ones that hold the house up. Those are columns. So I know that they are in the same column. Sorry, guys. I know that they're in the same column. So they are in the same group. And they both have 5 valence electrons. Emphasis on valence electrons. It's not the same number of electrons. They have a different number of electrons, but they have the same number of valence electrons. Try the next one, guys. It is oxygen and sulfur, and then you can check your work. So again, guys, now we're looking at oxygen and sulfur. Oxygen and sulfur in the same column. They're in group 6. So again, same group. Same group, which is group 6, which equals the same number of valence. Again, I cannot stress this enough. Valence electrons. So because they are in the same group, They have the same number of valence electrons. Moving on, parts per million to parts per hundred. So this one is pretty easy mathematic-wise. So we have 735 parts per million. So this tells me I have 735 over 1 million. And they want me to express this as a percentage. Whenever we go to a percentage, we multiply times 100. So I have like 0.01 times 100, that would give me 1%, right? So this is the exact same thing we'll do here. Again, I have a decimal that I will get here. So 735. Sorry guys, my little one's there. So when I get this answer, I get 0.123 735. So that is my decimal. That is my decimal point. I'm so sorry, guys. That is my decimal point for parts per million. I'm going to multiply this times 100 to convert it to the percentage that they're asking for. So my percentage would be 0.0735%. And that's it, guys. Super simple. I want you to try the next one on your own and then check your work. So you can pause me here. So again, 48 parts per million. So I have 48 over parts per million. So I have a million right here on the bottom. And I'm going to get my decimal. I know, guys, you're getting a free concert. So I have 4 zeros here. 1, 2, 3, 4, 48. And I'm going to multiply this by 100. This is where I am changing it to a percent. So my answer would be 0.0048%. Again, the practice is very easy. You have your whole number, what they give you, divide it by 1 million. You get your decimal, and then you multiply by 100. Papitas, guys. Nomenclature. I love nomenclature, guys. You should know your Greek prefixes by now. So we have mono, di, tri, tetra, penta, hexa, septa, octa, nona, and deca. These we should know. Remember, your first name stays the same. You don't change the ending. So here I have 3 nitrogen and 5 oxygen. So 3 nitrogen would mean I have tri. And the first name stays the same. Sorry, guys. So it's like when you get married. When you get married, your first name stays the same. So I have tri-nitrogen, but oxygen is going to be a little bit different. I do change the ending to IDE. They got married. You have a new last name, but I have 5 oxygen. So I have pentoxide. You change that ending. Pentoxide. So that tri-nitrogen pentoxide. Actually pentoxide. I'll double check on that one and make sure to give you the correct answer. And then here we have phosphorus and iodine. So I have 3 phosphorus iodine. So 3 means tri phosphorus. Again, remember your first name stays the same, but your last name gets that IDE. I have 5, so it's penta iodide. That IDE ending. You can also Google it, guys. I won't hold that against you to make sure you have the correct writing on it. Lastly, guys, we'll be going over breaking and making bonds. So here we have triple bonds, and they get converted to single bonds. So this means we broke bonds. So in order to break bonds, guys, you need energy. You need energy to have this happen. So this is an endothermic reaction. The opposite or the reverse reaction would be exothermic. But just remember, if you are breaking bonds, you have an endothermic reaction. The reverse reaction would be exothermic. The opposite, right? And now let's look at this next one. Exothermic, you make bonds. So I go from single bonds to triple bonds. I made some bonds. So made bonds. This releases energy. So this is a exothermic reaction. So the reverse of this relationship would be the opposite. So it would be endothermic. Hopefully this helps, guys. These are the easier type of questions you see on the final. I will get you a correction on the writing of the nomenclature. But again, guys, these you should get right. Make sure you have these notes available in a place where you can keep them. Have a great day, y'all.